Hey everybody, Dr. A here, and in this video we are going to be discussing rain loads. So rain loads are a most common cause for concern when you have a low slope or a flat roof system, okay? So what is a low slope and a flat roof system? Well, these are basically roof systems that do not have a high slope which would allow water to freely drain off or flow off the roof. So for example, if you look at a section view of a low slope or a flat roof system, you may have a parapet wall right here, and here is your roof system here, and then this is just a section view into the structure. So this is looking at a cross section. All right, so looking at a cross section, this right here is your roof, and it's very low sloped or possibly flat. And so whenever you have a low slope or a flat roof system, whenever it rains, water will tend to collect and possibly puddle on your roof system. And whenever you have this collection of water on your roof system, of course, that's adding additional loading. To your roof system. That's going to cause additional stresses and additional deformations or deflections of your support system. Okay, now if you have a high slope roof like a hip or a gable roof, of course the water can just flow right off of it. Okay, so it'll flow into the perimeter gutters, and you'll be fine. But again, this is more of a concern for low slope and flat roof systems. So what do we need to know about these kind of cases? Well, most of these roof systems, most of these low slope and flat roof systems have what's called a primary drainage system and a secondary drainage system. Okay, so we'll write that down. Most low slope roofs have what's called a primary drain system and a secondary drain system. Okay, let's see if I can spell things right. System, there we go. So if the primary system becomes clogged or blocked with debris, then you're going to need to rely on the secondary drain to drain the excess rainwater off. Okay, so let's make a note of that. If the primary system is blocked or clogged, we rely on the secondary system to drain the water off the roof. Okay, so what do these drains look like? Well, again, I'm going to draw another cross section of a low slope roof. Maybe it looks something like this. You have these parapets. A parapet's like a short little wall here that would prevent large objects from falling over. So it's sometimes called that a parapet wall. But anyway, a primary system, may be located somewhere in the middle of the roof, and it's usually connected to some kind of pipe. And this pipe could run from collect water and run on the inside, and then it comes out the outside through a wall hole, and your water can drain out this way. That's an example of a primary system. They don't always look like that, and obviously this is an exaggerated view. This is proportionally, this looks really big compared to the roof. But let's say that this primary system becomes clogged with debris, and so now your rainwater is starting to collect. Here, okay? So typically you also have secondary systems which are typically around the perimeter of your structure that allow drainage in case the primary system is blocked. So a secondary system may look something like this. It may be, it looks like a little slot in the around the perimeter in the parapet, and it could, transition to like a little scupper here, which drains out. Okay, and you may have several of these kind of spaced out along the perimeter of your structure, of your wall. Okay, so again, these secondary systems usually there's several of them, and they're called scuppers typically, but they allow water to come out through these little slots, and then they drain down a little drainage outlet along the side of the wall of your structure. So we sometimes call these things, again, scuppers. Okay, scuppers, and there's different types of scuppers, and again, scuppers are typically used as secondary drainage. Okay, secondary drainage systems. All right, so that's basically how it works and why it works. Okay, now how do we calculate the actual rain load? All right, well, the rain load itself, ASCE 7 and IBC 2018 call it R, and they say R equals 5.2 times DS plus DH. Okay, where R is our rain load in PSF. Okay, and then these other two terms, DS is called the depth of water, and that has units of inches, up to the secondary drain inlets, and then DH is called the depth of water, also in inches, above the secondary drain inlets. Sometimes DS is called the static depth, and DH is sometimes called the hydraulic depth. Okay, so these are depth values, literal depth values of rainwater in inches. And so you may be wondering, how does this give you a value in PSF? Well, this has a built-in conversion factor. Okay, so the 5.2 comes from 62.4 pounds per cubic foot divided by 12. Okay, so essentially what we have here for this equation, just giving you some background information on this equation, what you have is R equals gamma water times a depth, call it D, and if D is originally in feet, we divide by 12 to convert D to inches. All right, and basically what we end up doing is we end up saying R equals gamma water D over 12, and then what we can do is we can say gamma water over 12, we can kind of collect that term together, times a D value. Okay, and now since we have built in this 12 here by this statement, then now you use D in inches. Okay, now use D in inches, where D equals DS plus DH. So then of course we get R equals 5.2 times ds plus dH. So again, if you take the 62.4 PCF and you divide it by 12, you'll see you get 5.2. So that's just a little bit of background information about where this formula comes from. Just so you know, it's it basically just comes from the definition of hydrostatic pressure, right? It's just the basic definition of unit weight of water times a depth of water. Okay. So that is our first video on some background information on rain loads. I have a second video coming up where we give a general procedure on how to compute rain loads are based on ASCE 716. So that's coming up in our very next video. Thanks for watching.